Okie doke. I think it's just gone 5 o'clock in London. Welcome to the March SHAC seminar, which continues our series that we began during the pandemic and haven't seen any reason to cease. It's live on Zoom and also on YouTube. Could everybody mute, apart from me and Christopher at the moment, could everybody mute their microphone, please? And Christopher will talk for sort of 20 to 30 minutes, and we'll have a half-hour discussion or so. Those on Zoom, we will invite, if you can signal in the chat box that you want to ask a question, please do, and I'll call you forward at proper junction. Those of you on YouTube, I'm afraid you've got to put it in the chat box, the entire question in the chat box, and it will be passed to me, and I will ask the question on your behalf. So this month's speaker is Christopher Halm, who's a historian of science with a PhD from the University of Regensburg, and a practicing teacher of academic training in chemistry, history, and geography from Heidelberg University. He was awarded the Newcomer Award by the German Chemical Society's History of Chemistry Division for his thesis on agricultural chemistry in the 18th century. And as someone who has worked on agricultural chemistry, we're a fairly rare breed, so it's very nice to have somebody else working on agricultural chemistry at that time. He's an alumnus of the Heinrich Boll Foundation and has received several very important fellowships, including from the Science History Institute, Linda Hall Library, and the Leibniz Research Alliance. He's an active member of several academic societies and serves as an extended board member of History Chemistry Division of the European Chemical Society, or EUCHEMS. His research at the moment focuses on history didactics and history of chemistry from the early modern period to the present, with particular interest in the historiography and epistemology of spaces of knowledge production, especially the laboratory, the field, and the museum, which covers about everything apart from the office, I suppose. He currently resides in Munich as a visiting research fellow at Deutsches Museum, where he's working on a new book project exploring the global history and technoculture of moon rocks, and that is what he's going to talk to us about today: escaping Earth, sustaining the moon, the chemistry behind public narratives of lunar habitation and cosmic age. The floor is yours, Christopher.
Great. Thank you, James, for the kind introduction. I'm honored to present at this online seminar of the Society for History of Alchemy and Chemistry. And now it's my turn to share the screen again, right? So I do this. I think it takes a while.
Yeah, there's a little circle.
Yeah, moment.
There we are.
It should start now.
That's it, we're there.
Great, wonderful. So, as some of you may have anticipated, my presentation titled, as James just said, Escaping Earth, Sustaining the Moon, the Chemistry Behind Public Narratives of Lunar Habitation and Cosmic Age, is not merely a historical account of the moon. Instead, and I believe I can express it this way, given to our group here, it reflects on our history as Western Northern Knowledge Society and the effects of its globalized technoculture in the 20th and 21st centuries. To state it up front, I have put the term chemistry in my title in quotation marks, following the intention not to focus too much on the contributions of chemical analysis or chemistry as a discipline. Rather, I aim to explore the role of specific phenomena within the history of chemistry, alongside both the influences of American policies and the practices of museological commemoration concerning the Apollo program, which underpin current ideas of lunar habitation and cosmic age. To clarify, my presentation will not offer finely polished argument about the history of lunar science. Instead, on the one hand, I will share glimpses from my ongoing research project titled Moon Rocks, the Global History and Technoculture. And on the other hand, I will connect some insights from this research to my central claim today, namely a societal drive towards sustaining the moon. So, that was one too much? Yeah. I focus on two principal observations drawn from my research. Observation one, in context to NASA's Artemis program, for those unfamiliar, this is for the Western world, the current major lunar landing and habitation mission led by the United States, in close cooperation with the European Space Agency and several small and large corporations, most prominently SpaceX. So in this context, a significant portion of today's space exploration research and public relations are heavily imbued with terminology and imagery that evoke strong associations with ecology. From a present-day perspective, the emphasis on the term sustainability is hardly surprising, given the vast consumption of resources, both financial and material, particularly in light of the pervasive discourse on the climate crisis that we, in Western societies, encounter daily, at least in our newspapers. Moreover, when considering an argument by Karen Nicholson and David Munce, who posit that early spaceship research in the 1950s and 60s preceded key concepts of the environmental movement, the current terminological and visual convergencies between space exploration and ecology become historically explicable, seemingly even logically sequential, at least on one level. What is surprising, however, is the bluntness with which NASA, along with collaborating and independent institutions, employs terms such as sustainability alongside imagery that repeatedly depicts, for example, small fragile green seedlings, framing them as deserving of careful protection, and self-preserving stations ostensibly suitable for sustaining human, crop, and machine life on the moon. When institutions request lunar samples, now I switch a little bit now the idea. When institutions request lunar samples from the past Apollo program, NASA has even defined specific messaging and talking points emphasizing the sustainable aspect of its new program. These points shall be addressed when displaying lone moon rock objects. So I do not intend to justify this bluntness, but I do wonder and question how this mode of communication and representation should be historically classified and contextualized. To provide a part of a bigger framework, I would like to introduce the second significant observation from my research. This next observation is dual in nature and relates to the public and science history of moon rocks. It is as follows. The Apollo program, completed in 1972, along with its timely political, public, and scientific implications, marked a turning point in the 20th century as, and this is my crucial claim, it offered both a spatial and temporal exit from the horrors of the Second World War. This exit was and still is offered to all nations and peoples willing to participate cooperatively, or perhaps better put, competitionally, in space exploration under American leadership, potentially even following a broader American model. Notably, the degree of participation has not always been clearly defined either by the US or by associated nations, resulting in a fluid range from active contribution to passive observation. So using examples from the biographical episodes of several selected moon rock objects, I will substantiate my claim of the spatial and temporal exit. To emphasize upfront, My study examines the multiple societal and techno-scientific, global and cultural past and thereby potential future values of moon rocks. I focus on the one hand on lunar sample objects that are stored, catalogued, and exhibited in museums in nearly every country worldwide, and on the other hand on samples that have been meticulously scrutinized in chemical laboratories. My research, therefore, elaborates on the identities of these samples and how their identities have evolved over time. For today's presentation, I will primarily limit my discussion to West Germany, the United States, and to some extent to China. In reference to these three political entities and as a part of the broader argument in my study, I assert that moon rocks have been deployed as auritic insignia symbolizing participation in power, knowledge, and civilization. In very quick fashion, I plan to demonstrate how moon rocks have been used, misused, reused, many other kinds of use in A, establishing political, cultural, and scientific narratives of progress and success, B, reinforcing civilisational claims, C, delineating historical epochs, and D, fostering both national and international competition. Let us begin on the moon. I would like to engage you more actively by taking you on a mental journey, one that illustrates the key aspect of my research approach. Imagine you are a moon rock. Let us assume you are the one here in the middle part of the picture, very close to the astronaut's boot prints. For approximately 3.4 billion years, you enjoyed a remarkable view from your front yard. After a long period of intense cosmic radiation and powerful meteorite impacts, you settled into a fairly calm, solid, and rigid existence for roughly 300 million years. For now, I will skip the details on how these time estimates are determined. Back on the moon, then after all those millions of years of serene silence, suddenly these two strange figures appeared in front of you. Behind reflective helmet visors in shiny white suits, the American astronauts Eugene Cernan and Harrison H. Schmitt of Apollo 17 surveyed the landscape once so familiar only to you. After several hours of exploration and experiments, and meanwhile on the way back to the lunar landing module, Schmitt, a trained geologist and so far the only scientist to have walked on the moon, picked you up with his chunky gloved hands. To make room for you in his professionally termed big bag, he promptly discarded two other collected rock samples, disposed of your relatives, so to speak. And so, on December 11, 1972, according to human timekeeping, you were removed from your native environment for the first time in your existence. For Schmitt, at that very moment, you were a valuable find in scholarly field research. To this end, your surroundings were carefully photographed, mapped, marked, gridded, and numbered, which, in Bruno Latour's terms, transformed the wilderness of your environment in a proto-laboratory. An information plaque accompanying a 40-year-old diorama at the Deutsches Museum in Munich presents lunar field research as well-organized, structured, and perhaps even a multi-synchronous act of orderly measurement and experimentation. The message conveyed is that science occurs systematically, thoughtfully, and through high complex technical instruments. Yet, this portrayal of lunar field research contrasts sharply with the clumsy movements and playful hopping of the astronauts on the moon, an image all too familiar to the global public through countless television reports. Moreover, it overlooks the fact that Schmidt, in his haste and excitement during his encounter with the moon's environment, forgot to record your exact location. Moreover, there's something strange. Moreover, the laborious use of rakes, drills, shovels, and geologists' hammers, often framed as subsidiary elements in space exhibitions, further confirms the adventurous and colonizing undertones of moon landing missions rather than their scientific pursuits. So let me see, I can start this.
Jack has picked up a very significant
Let us
rock.
linger a little bit longer on the moon and recall your situation as a moon rock, as described earlier. As being lifted from your home spot was not shocking enough, shortly afterwards, you even became a media sensation, following a political assignment proclaimed before worldwide television audiences. In Cernun's closing speech, with the rather sentimental title, Moon Rocks to the Children of the Earth, the two astronauts theatrically presented you in front of the American flag. While Cernun juggled you, he addressed in his own words the younger generations of all countries and peoples of the world. Moreover, he made an arbitrary comparison between your geological texture and consistency and, in an unfortunate analogy, the diversity yet alleged equality and unity of the people on Earth.
In peace and harmony in the future.
After that, you were placed back into the Big Bag. Colonial treasure secured, mission complete, next stop, Earth. So what happened on Earth? You were assigned the sample number 70017. You were photographed, sawn, and fragmented into tiny pieces, resulting into a series of subnumbers. While some parts of you remain stored in the Lunar sample vault in Houston, Texas, other portions were sent to various research laboratories for chemical analysis. Speaking of analyzing moon rocks in laboratories, in Germany, 4 institutions were designated to receive lunar samples for investigation. The Max Planck Institutes for Chemistry in Mainz and Physics in Heidelberg, and the universities of Cologne and Tübingen. As common practice, researchers at these institutes, such as Heinrich Wenke, leader of the Cosmochemistry department of the MPI in Mainz, cut off small crumbs from pieces of moon rock samples provided by NASA and dissolved them in highly concentrated purified sulfuric acid. For the purpose of radiometric dating and mass spectrometry, you, now a moon rock crumb dissolved in acid, experienced tremendous heat while being surrounded by protective gas. At around 400 degrees Celsius, you transitioned into an ionic state. Immediately afterwards, you accelerated to speeds of up to 1,200 kilometers per hour before passing a magnet. Finally, your various components were thrown onto a collection screen. Following this procedure, your late atomic traces were transformed into numerical and graphical data, contributing to a myriad of scientific articles. Today, the outcomes of these quantitative and radiometric analyses are applied in the development of advanced 3D printers, as well as furnaces and smelting systems designed for on-site construction of lunar bases. For quite some time now, these analyses have found their way into the museum, or at least the results, and usually give brief age specifications on inflammation packs. In the case of the Senckenberg Naturmuseum in Frankfurt, the process of musealizing lunar research has involved integrating instruments and even former researchers into its curatorial work, consequently into the exhibits and broader public outreach, at least in Germany. Bearing this in mind, it becomes apparent that the Max Planck Institute retains interpretive authority over its role in the history of lunar sciences, perpetuating narratives of progress, ingenuity, priority, exceptionality, innovation, and technological superiority. Excuse me. Senckenberg's reliance on a privately and institutionally biased in-house expertise, primarily rooted in experimental science, vividly hinders historical debates and topical approaches to future exhibitions. As a result, the Senckenberg struggles to meaningfully integrate its lunar sample object within its exhibitions and broader agenda, which centers on animals, plants, life, and regional ecological issues. Unsurprisingly, Senckenberg's lunar sample, originating from Apollo 11, spends most of its existence stored in an old kitchen radio box inside a drawer. This is an empty slide. The Senckenberg is just one example among many. To broaden the investigational scope and consider the narratives that have been disseminated over many decades, let me briefly highlight one example that, whilst bordering on the grotesque, has served particular science policies and Machtpolitik. A portrayal that persists to this day suggests that lunar samples had to be lifted from the moon, transported to Earth, stored both short and long term, and transferred to research institutes, all of it without any contamination. Native purity and fastidious precision have been established as fundamental requirements for obtaining reliable chemical analysis results. As in other prominent cases in the history of science, propagating the ideals of the modern laboratory as both the means and catalyst of evidence and scientific rigor asserted knowledge authority. Supporting the sterility and precision narrative, in 2012, the Max Planck Institute in Mainz produced a promotional film with text overlays based on historical Super 8 recordings. The film narrates how the moon came to Mainz. In contrast to the film's message of precise knowledge through sterile purity, search and past occasions tell a very different story. For example, when the Institute received lunar samples for the first time in 1969, several specimens were intentionally examined by hand during photo shoots to publicly stage the Institute's and its members' international prestige. Furthermore, unpublished recordings even show how similar moon rocks were ceremoniously placed at the center of a dining table while the MPI's researchers and associates gathered in a cozy, festive atmosphere. The participants of these events, particularly Wenke, seemed fully aware of the humorous paradoxes inherent in these situations, visibly enjoying the moment, as you can see here. From a geological standpoint, and arguably from a fine analytical cosmochemistry perspective as well, the vigorously communicated sterility dogma appears unnecessary, inordinate, excessive, and somewhat misguided. From a historical perspective, it can be stated that the sterility narrative was intentionally initiated by NASA and further promoted by its international partners to uphold scientific, political, and civilizational claims of power. As such, it has proven and continues to prove technoculturally robust. Only a civilization capable of working exceptionally clean is deemed worthy of exploring lunar rocks and appreciating their significance in understanding the moon, the earth, the universe, and consequently in assessing our place in all of it, both now and in the future. To echo and build upon two arguments, one by John Creech and the other by Helmut Trischler, regarding the establishment of the European space program after World War II, it can be argued that emerging space nations such as China are reproducing and extending this and corresponding narratives to their own benefit. China positions itself as the author of its own sterility narrative, sending an implicit political message of technological and civilizational advancement, thereby asserting and presenting itself as worthy. Switching back from chemistry and power policies to the role of moon rocks in museums, and from there to the claim of sustaining the moon. When entering the museum Haus der Geschichte, House of History in Bonn, visitors begin in a constructed basement where they are immediately confronted by an air raid bomb that hit but did not detonate. The setting relates to Germany in the year 1945. As visitors move from floor to floor through each exhibit section, they gradually traverse time, experiencing the 1950s, 60s, and so forth. On the top floor, a large ramp leads directly to a centrally exhibited lunar rock, situated just below the museum's roof. Beneath this ramp, though barely noticeable to the visitors, the crimes and horrors of Auschwitz are addressed for the very first time within this museum. The message, as I interpreted it, is that we cannot escape Auschwitz on any earthly scale. To escape, humans had to leave the old world, that is, the Earth, and arrive at a place untouched, the moon, and moreover, bringing something back from there in a presumably still pristine state. Reinforcing this escape on a spatial level, and to add more extraordinary distance, as with several other moon rock samples on display, the cosmic age of the sample is attached to the object. This age is chemically certified and, crucially, of even greater unimaginable, mentally impalpable scale. Or can you grasp the meaning of 3.3 or even 4.2 billion years? As part of Richard Nixon's evolving peace agenda, and thus in conjunction with the end of the Vietnam War, among other historical events, this spatial and temporal escape closed the first long half of the 20th century, and opened a door to a new, globally conceived, civilized, and cooperative society. Well, maybe. Is the currently emerging new space age also serving a need for escape, this time from the impending climate crisis rather than the horrors of war? New exhibitions and research programs focused on the colonization of the moon and subsequently Mars at least suggest the possibility of seeking refuge beyond Earth. But let me end with a slightly more nuanced conclusion. I would like to include and reflect on another recent argument by Latour given in his publication Où atterrir, Where to Land. I'm not joking with the next statement. Trumpism is the first in its first tenure marks the first government entirely focused on the question of ecology, albeit through rejection rather than engagement. Yet, it is not necessarily about denying the existence of climate change as a whole. Climate changes all the time is a popular phrase among Republican politicians in the US, but rather about diminishing its significance, or at least its relevance for US citizens. According to Latour, this diminishment is achieved through the proclamation of a new attractor, the conquest of the extraterrestrial, the moon and Mars. The Trumpist message is no one, meaning no American and close ally, need to be overly concerned with the present state of the Earth, as this state will remain stable long enough, not just for human survival, but also for prosperity. Moreover, the situation will last until we, the Americans, through our own actions and achievements, decide to leave this state behind, essentially by fleeing from Earth itself. So, to conclude from a historical perspective, while Apollo provided an escape from the near past through an escape into the deep past, the Artemis program is an escape from a present fear of a near future through a materialized outlook into a distant future. In this context, NASA's use of ecological terminology reflects a pressing need to free humanity from the paralysis caused by ecological, economic, and political dilemmas of global warming. And notably, this need is not exclusive to Trumpists, climate change deniers, or Republicans. Sustaining the moon serves as a power strategy to relieve anyone, explicitly or implicitly, willing to be involved in space exploration, whether actively or passively, scientifically, politically, or economically, and magically, even regardless of their stance to ecological issues. In essence, sustaining the moon signifies liberation from the constraints imposed by ecological awareness. It reclaims agency not only for political leaders, but also for every individual, irrespective of justified accusations of irrationality. It is a reflex that has evolved into a historical counterdraft to the movement of sustaining the Earth. One final remark. Chemistry, and specifically cosmochemistry, continues to promote this easing of conscience. In cooperation with politics, economics, and other scientific disciplines, it contributes to a new exit, this time from the mental constraints, urgencies, and rigors of ecology and environmental responsibility. Thank you for your attention.
Thank you, Christopher. That was a really interesting argument you've made. I've got a lot of questions, so I'm going to use my chair's prerogative and ask the first one, and then other people can sort of ask questions, and I can come back to my ones if you've got time. The one person whom you did not mention in your talk was Elon Musk.
Yeah.
And it seems to me that the sort of current American space program, including one here, sort of very serious cuts to the NASA budget, is being driven by Elon Musk. And I have read an article, now whether this is accurate or not, it's very hard to tell in this day and age, that when he was a young man, or even a teenager, he read sort of works by Isaac Asimov, the Foundation trilogy, and all those sorts of things, which sort of have as their basic premise that humankind was spread out from Earth to take over the rest of the galaxy, completely ignoring ignoring laws of thermodynamics, so far as I could make out. Is this where this is coming from? And is it? I mean, was tempted to use the sort of unscholarly word like bonkers, but it's the only thing that does come to mind to describe this mindset that seems to be engulfing science policy in the United States. So I'm just wondering what your take on Musk and how sensible this is.
Well, of course, Elon Musk plays a significant role in all these developments, and the SpaceX program is so strongly connected to the Western space programs. Well, I do not know yet, or I do not know his personal biography yet. When I prepared the lecture, this was before even the election. The big election campaign started last year, and so I cannot point out Musk as the key significant contributor or big mastermind behind. But what we can definitely assume is that this whole so Northern California, Berkeley, not Berkeley, Los Angeles, Berkeley, Center San Francisco area, with the early ecological movement there, that is basically so they are the same persons who are going into the Silicon Valley and developing software, developing new technologies. They are also these people who are there running the environmental movement, and they have a new idea of in the future of how all these environmental movement can be turned out. And so I think it's not just Musk, it's this strange 70s, 80s Silicon Valley Bay Area environmental tech cultural sphere that now in our today's space age has their fingers in and try to get their ideas materialized.
So sorry. Are you saying that these people think that it is that all the problems we've got in terms of environment and whatever are fixable by techno science of some sort, and that includes going to the moon and to Mars?
Well, I would not say that, but
no, you wouldn't say that. But is that what you think they're saying?
I doubt that. Well, I think some of these people, and then we would need to make a very strong survey on specific people. I have never done that, but I think some of these people really believe that. But I doubt the majority would believe that they can use that they can fix ecological issues, or even that they cannot fix ecological issues by just leaving Earth. But I think it's not so important if they believe it or not believe it. The important thing is that they can use this narrative for other purposes. For example, in gaining funding for rocketries, getting awareness, they can legitimize rocket programs, rocketry programs, space flights on ecological terms, which is crazy.
I might come back to that. Any, if you've got questions or comments, please put your hand up or put it in the text box. Mike, do you have any comments? You're muted.
You're muted.
Done it. Right. I must say that the handling of the space rocks, the idea that on one hand they make out that they're being handled in a sterile fashion, and simultaneously they're sort of handling them over the dinner table.
Yeah.
It is most bizarre. Do you know what proportion of moon rocks were properly treated and what proportion were abused?
No, I cannot say. And I mean, there are thousands of sometimes just tiny chunks that are spread out by NASA and distributed. And we do not know which are treated properly and which are not. But this is for further research on my project. There are moon rocks. There's a database for moon rocks, and if you click all through the different moon rocks and the different numbers, sometimes you find a moon rock a number to a moon rock, and then they're stated, well, this is not good for use anymore because it is contaminated. So at least there's a notice, a note that some moon rock samples are not clean anymore and should not be used for radiometric dating. But it does actually not necessarily mean that they are no use. They are not good to use for anything. I mean, you can still do very fine quantitative and qualitative analysis on them. Yeah. Mm-hmm.
Okay, so can I go back to this sustainability issue?
Yep.
I mean, I keep on reading in scientific magazines of plans to go to asteroids to mine them for all the rare earths that can only apparently be found in China or the Ukraine. And try as I might, I cannot imagine how A, you would actually do that, and B, how you would bring it back in an energy efficient way.
Yeah, I don't know either. But I know there's still people, also especially in the Bay Area, who dream about a what's called space elevator. So the idea is to build extraordinary huge nanotubes, carbon nanotubes, and within these tubes there shall be an elevator, and the elevator shall go up to the outer space and to collect or to gather the samples that are collected. Yeah. But this is not actually my research. My research is mostly on moon rocks past values and potential future values. So I concentrate my research on moon rocks in museums and laboratories, and try to draw arguments that extend the laboratory and the museum.
I mean, yeah, I mean, I take that point, but I mean, it's actually, I mean, this is I think this is why your argument is so interesting, because it sort of plays into sort of future scenarios, which is deeply concerning.
Yeah, I think it's very concerning. Yeah. Yeah, and it's interesting how long actually the story is already going. I mean, we have these moon rocks now on Earth for 50 years, and of course they're because of some lack of interest, maybe in the late 80s and 90s. People didn't pay attention to it, but the narratives are kind of that with the space age, they are so much entrenched or imbued in put into these moon rock samples that are distributed worldwide. So basically, it doesn't matter where you are on Earth, as long as you are able to get into a national museum, you are able to see a moon rock. And you will receive Richard Nixon's message coming with the moon rock, and yeah, I mean this. Yeah. Any more questions, maybe?
Yeah.
Or maybe a question. Yeah, there's one. No, somebody has to leave.
It's actually your point of people like Musk suggesting space is a good thing for humanity is an interesting one. Enormous amounts of effort go into various aspects of scientific endeavor, for instance, particle physics, cosmology, astronomy, all very expensive. And this is by respectable people, not people one feels a bit queasy about. And it does seem that if you believe, as most people do, that climate change is a serious existential threat, that putting vast amounts of energy into cosmology, particle physics, and now exploring the planets, and losing high quality scientific brain power when there's an existential threat, climate change, with which we are not coping, is not a good thing. It's not merely Musk who's proposing strange things. Respectable people are, in a way, shutting their minds to the existential threat.
Yeah, I would agree on that. But I mean, the thing is, people like Musk or just the whole Trumpism, they give, so the Trumpism gives these people a legit claim, even if it's even if things sound strange, but the whole political dynamics and is so structured that this Trumpism found a way to kind of reasonable argue their point. I mean, and I can see that. Well, at least I believe there are even respective researchers in physics. They kind of feel maybe a little bit happy about it, because it allows them to focus on other aspects or in their research. So, yeah. I mean, you can even claim a rocket scientist that's just 5 or 10 years ago, let's say 10 years ago, people would address him with the blunt question, are you sure about doing rocket science? I mean, this puts all the garbage into the atmosphere. It's totally expensive. Won't you use your smart mind for better things to help the planet, help animals, plants, and human life? Now the rocket scientist can basically point his fingers to Trumpists, or include himself to the Trumpist movement, and basically make the argument, I'm part of a bigger environmental movement. My environmental movement extends this planet. My belief environmental movement extends our own time, so our own period. So I'm basically preparing our safety up into the future. And it doesn't matter if he convinces other people. As long he is convinced from these words for himself, or as long as he can use these arguments for what he wants to do. This is rocket scientry.
But has anybody actually done a sensible study about how you can sustain a long-term colony on either the moon or on Mars? And by long-term, I mean sort of looking at sort of say 100 years out. Suppose during Trump's presidency, a colony is set up on Mars now. Has anybody ever done a study suggesting how that would actually be managed and survive until 2125?
So I do not know what happened in Trump's first tenure and what NASA did distinctly as a study to create a sustained habitation on Moon or Mars. But what we do know from historical perspective is that actually these plans and these studies are very, very old. There are programs, drafts, exposés for lunar habitation and Mars habitation that are from the 1950s and 60s. And that's not only in the US, it's also in the Soviet Union. So
but are they even remotely practical, or are they just somebody's science fiction make-believe?
Yep. I mean, it depends on who you ask and how he understands what sustainability actually is, and to what time, from what time scales we are speaking when we speak about sustainability or maintenance, and not just time frames, but also on what actually so what life forms they are speaking about when they're speaking about sustainability. Is it human life, or is it are they speaking about microbes or other kinds, or is it plants? So I mean, also the thing is, the whole idea of extraterrestrial sustained habitation as a real science, as a real political program starting in the 1950s and 60s, did not just abruptly end with the end of Apollo. The program extended through time. This is why we have the ISS, This is why we had the biosphere program in the United States, and this is also actually, and you can maybe even draw the arguments that some people of these, like Musk or other people and people that go along with him, they would maybe argue, well, of course we have a sustained habitation already on Mars. Curiosity and other other Mars rovers are moving around there, doing research up on Mars already for several years. So
that's taking a slightly Victorian view, which is not something I associate with Elon Musk, I have to say. Okay, so I think time is up. I'll draw this to a conclusion. Our next seminar in this series will be on the 22nd of May, details announced in due course. Can I remind you that we have a biography meeting at UCL on the 29th of March, that's this Saturday. If you haven't booked, just turn up, and I'm sure the treasurer will be happy to take subscription off you. And also on the 11th to 14th of June, the ICHC meeting will be held in Valencia. SHAC is sponsoring one session. We're presenting the Morris Award to Peter Morris as sort of his work on, as a recognition of his work on 20th century chemistry, but also SHAC sponsors ICHC to a much greater extent than just those two. I mean, when I was at the last meeting in Vilnius a couple of years ago, I could, but not quite, but about a good half of the papers will refer to SHAC in one way or another, or Ambix, which was very, very gratifying, I have to say. Now, seminars like this don't happen of their own volition, and I'd sort of like to thank Anna Simmons, Rob Johnson, Caroline Cobbold, Becky Martin, and Chris Campbell for all their contributions, but most of all, obviously, to thank Christopher Halm for giving a really interesting talk.
Nice.
Thanks. I haven't seen anything quite like that before. Okay, anyway, thank you, Christopher. Enjoy the rest of your evening wherever you are, and hopefully see you in a couple of months' time. So thank you.
Thank you too for inviting me. It was fun. Thanks.
Okay, bye.
Bye-bye.